Let's start today class. Good afternoon, everybody. How are you doing today? Are you doing very well? Not like me, I was sick during the week. Okay, guys, let's start today's lecture. Answer these two questions regarding previous lecture. Now it's 1:23. I will give you 4 or 5 minutes just to answer these questions. I will show you the results. We will have a new lecture about the work and energy for today's lecture. Can I show the results? What is more time? Okay. Let's see how much studied previously. And show the results. First question, 68% answered correctly. Second question, 57% answered correctly. Yeah, let's go to the test. I started to talk about equation of the motion in cylindrical coordinating system. And I show you for some complex problem and also different applications I showed in the previous slides. We need to use the cylindrical coordinating in the 3D or the polar coordinating system in the 2D one. To show the and to use the equation of the motion in the radial and transverse coordinate system, we need to draw free body diagram. And I explained how to draw free body diagram in the previous lecture. There are several forces applied to the particle moving along the curved path. And one of them is, for example, normal force. I explained that if it's this particle is moving along this curve, and at this position, we can find the position of this one using r vector, and we can draw the radial axis and theta axis in this direction, and also we can draw a tangent line tangent to the path at this position. Now, I explained that in the previous lecture. For example, for a rock or a particle moving on a straight path, how we can draw the normal force. We can draw the normal force perpendicular to the direction of the motion. For this one, if I draw the tangent line, that is aligned with the direction of the motion, normal force will be perpendicular to the tangent line. Also, for this one, approximately here, normal force also will be perpendicular to the tangent line. Means that the first question, C is the correct answer. For the first question, doesn't mention any type of the motion. For example, it's a rectilinear, it's a curvilinear. For any type of the motion, you will see that normal force, it is tangent to the path. For the second question, when the forces acting on a particle are resolved into cylindrical components, frictional forces always act in the I explained also that if this particle is moving this direction, the frictional force will be in tangent line in opposite direction of the motion. Similar to this example. This is the direction of the frictional force, opposite direction of the motion, and along the tangent line. For the second question, D is the correct answer. Any questions? No questions. Any question from previous lecture? Nothing. Okay. Can I move to the next slide? Yes. Good. I started to talk about the work. What is the work? And I want to just start from beginning again. For today's lecture, I want to show you what is the work of a force. You already know this one from physics. Okay. You know the general equation, how to find the work of the force from the physics. I want to develop this idea for any type of forces and for any type of the motions. And I will show you the mathematical expression, how to find the work of the force. Those what I find in here and also for today's lecture exactly consistent what you learned it before. They support each other. Okay, I do not want to oppose or say any different what you learned it before. And also, I want to, for the second part, we will discuss about the principle of the work and energy. And you will see some applications, how to find the work of the force for different forces. And finally, I will show you the principle of the work and energy and solve examples. And we will wrap up today's lecture. There are several applications regarding why we need to learn to find the work or energy of the system, or energy of the particle, or energy of the body. First one, in automotive engineering or braking system, work done by braking force. If you apply a braking in a car, you apply force and apply this is a work to stop your car, and some energy will be dissipated. You will see some, for example, sometimes in that kind of those racing cars, you saw some smoke coming out of the brake pads. And this energy dissipated and also converted to the thermal. And also, you want to see how much stopping distance after using the car work energy to it. Second one, the roller coaster, just I also thought this one, how to conserve the potential energy, the kinetic energy, and vice versa. The next one is the cranes and elevators. How much work is needed to just lift kind of this heavy load? Or for spring and shock absorbers, you saw that some energy will be stored. If you just store it in a spring, energy will be stored, and when you release this spring, the energy will be conserved and also will be transferred to another time. Another one is this area regarding impact and collision analysis. If some of you are working on some automotive companies, they have one section for regarding the impact and also there are safety engineers. They do some analysis on accidents on the car, doing some impacts on the car, and measure the energy that is kind of absorbed during the accidents. If you saw some of the videos in the internet, that how they design the cars to make a kind of car safe for the passengers during different accidents. Also, we need to find and also use the work and energy for fluid mechanics, pumping system, and fluid dynamics. In other areas related to the engineering, such as aerospace, biomechanics, and also renewable energy, also we need to find the work and energy. As you hear from me several times, I just mentioned work and energy, how we can find those ones, I will explain today in complete form. Now, when I ask you, I remember I asked you this question, how you define the work. Most of you answered that work it is force multiplied by displacement. Then I asked you that is any type of force do the work, and then we concluded that not any type of the forces. For example, that forces that they are perpendicular to the direction of the motion, they are not doing work. The only forces that are doing work, they are forces that belong in displacement. If I push this one here, this will be moved. However, if I just push vertically, okay, this one doesn't move. This one does just stand here. Means that I need to just apply a force along this displacement to move this one, doing some work. This equation is an equation that we can't find the work. I use the notation U here, but as I explained it before, to show the work, I use this notation. But it's up to you. You can use whatever you used it before. For example, when I was an undergrad student, we used W to show the work. Okay? Whatever you want to use for the notation and also symbol of the work, feel free to use it. Just do not confuse with those notations. But I want to stick to the reference that I will use. Now, the amount of the work that is done by the force F, that cause this particle moves from A to A prime with the displacement of the dr, differential displacement of the dr, can be found from this equation. du differential work equal F dot dr. Dot, you will see that this one is a vector. Also, dr also will be a vector too. But I use the dot product. Dot product of two vectors, such as A and B. A and B represents two vectors. How we can find the dot product of the A by B? Does anybody know how we can find the dot product of two vectors? Do you remember from calculus? Yes.
We would multiply both the x values with the root together and then add that to the multiply both y values and then multiply both the z values. Or I guess that's not the best way to describe it. But
You are close. I will use this one on the next exercise. But general form, for example, I have the vector A and vector B. How we can find the dot product of two vectors? The dot product of two vectors can be found. The absolute value of the A, or the magnitude, absolute value of the B, multiplied by cosine of the angle between A and the B. Now, I just explain how we can find this one. If the product of this one is C, now C is C a scalar or is a vector? Scalar. C, the product of A by B, it's a scalar. Now, what I can conclude from this one for the word? Can somebody tell me? This general form I show you, the dot product of A by B is C. Now, how about the work? Work is a scalar or is a vector? Yes.
Scalar. Scalar.
You want to see? Say. Might be a different idea to say it. Correct. Yeah. Work also is a scalar. You will see here, work is a scalar. It doesn't depend to the direction. Just this one's the number. Now, what I want to show you, another alternative terms of this expression. What is the alternative term of this expression? Now, if I use and find the component of this normal force, you remember the tangential direction and normal direction? Do you remember? If I find the component of this force along the tangential and normal directions, this angle will be alpha. It will be the tangential component of the force will be F cosine alpha the normal component of the force is F sine alpha. Now, using that one, I show you that du is the F dot dr. Okay? Using this one, this relation, it will be the magnitude. The F absolute value of the dr multiplied by cosine alpha. Now I just write there how to just say can be multiplied. Then F cosine alpha. What is F cosine alpha? What is F cosine alpha is called? What? Yes, Ft. Also, I show you that dr has a magnitude that's called ds. The magnitude of the dr is the ds. Also, instead of this one, also I can write ds. Now, this one is equal to Ft ds. What does it mean? It means that the amount of differential work is equal to force along the direction of the displacement. This is exactly, this equation exactly consistent what you answer my question. Car is force multiplied by displacement. But what type of the force? Force that is along the displacement. You will see here that there is no normal force. The only force that's doing work is the force along the tangential, or force along the direction of the displacement. Okay? What I show you here, the mathematical expression of the work to find the work of any forces, any type of the motion, is a rectilinear if this one is moving on a rectilinear motion. Look, if P as applied to this one. For example, Ft will be P cosine alpha. If this one is angle of alpha, Ft will be P cosine alpha. This one will be doing a work. Similar to this one, or F or P. If just this one is moving on a curved path along tangential direction will be F cosine alpha multiplied by the displacement, that the displacement is ds, means that another alternative expression for the work is du equal to ft ds. Now, these are the notes. Something does nothing. Only the component of the force in the direction of displacement does the work. The next work is positive if the tangential component of the force is in the same direction of the displacement. In physical meaning, just if I apply a force along the displacement, I just do a positive work. However, if one person stands on another side of the table and push forces in opposite direction, it will do a negative work. It stopped me to push this one. This equation is just that instead of the ft, if this minus ft, the work also will be minus ftds. Regarding your life, always mention that just find friends who push you to the positive work and energy, and avoid some friends and people that affect your life to just return back or give you a negative energy. This is also consistent with your life. If somebody pushes you to study dynamics, it's a good friend. If somebody pushes you not to study, not good. Okay. Can I move to the next slide? That's exactly what I mentioned. Work is positive if ft is in direction of the displacement. The normal component, this one, does not work because it's perpendicular to the displacement. From here, from this, if I write instead of f, I just put fn. And also, dr also is a displacement. But what's the cosine alpha? This is fn, this is ds. How much is the angle? How much? How much is the angle between fs and ds? How much? How much is this angle? How much is it? Yes, 90 degrees. Guys, I know that after the dinner, after the lunch, just to make some kind of sleepy and also just follow me. Okay, guys? Fn is perpendicular to the ds. This alpha, it is 90 degrees. This is the reason this one becomes 0. Means that the amount of the work that is done by Fn is 0. I show you using this equation. Whatever you learned before, I used one expression to show you that, for example, if Ft is a long displacement, is doing work, if it's perpendicular to the displacement, you got to do work from this equation. Any questions? No? Units of the work, I will spend 10 seconds. Work is force multiplied displacement. Force is a Newton in the SI units multiplied by the meter, or the units of the work in SI unit is joule. In US unit, it is foot-pound. That's it. Now, You learn on this slide how to find the amount of the work that is done by F on this differential displacement. How about that? This one starting from here to here. What is the work that is done by this force for the whole pass? How we can calculate this? To calculate the force on the whole pass, we need to take the integral from previous equation. du is the F dot dr to find the amount of the work for the whole pass from position 1 to position 2 or state 1 to state 2. We need to take the integral from 1 to 2. Now, how this one is coming from? And what are this? Can somebody guess? First, what is fx, fy, and fz? What do you guess? Yes.
Is it the force in the x, y, and z direction?
Correct. Yes. How about the dx, dy, and dz? Step by step. Yes.
Is it the position in the x, y, and z direction?
The displacement. Correct. Yes. They are the displacement along x and the y and z. Now, how we found those ones? Using the dot product of two vectors. If I write the f in terms of the sorry. If I find the component of the force along I, J, and the K, I write the F in terms of the component along X and the Y. And also write the components of the displacement along X, Y, and Z. If I substitute them here, substitute F into here, substitute dr into here, and do the dot product. Do the dot product. For example, to do the dot product, we need to multiply fxi, just first term, dot dxi plus dyj plus dzk. And I will continue for other terms. But for this one, first one is the fx dxi. This will be fxi dot dxi. Can somebody know and tell me that how much is the dot product of fxi dot dxi? But let me just make this one more simple. How much is the dot product of I by I? 1. How much is the dot product of I by j? How much? How much?
0.
0. To do this one, these are only numbers. This will be fx dx, I by I, that is 1. Other terms will be 0. Why? Because I by j will be 0. I by k also will be 0. These are 0, these are 0. This is the reason we have one fx dx in here. If you continue this one for fy and fz, you can find other terms. What are they? Fx dx is the amount of the work along x direction. Fy dy is the amount of the work along y direction. Fz dz is the amount of the work that's moving along z direction. Or alternative form of this one from previous slide, we found du is the F ds. Also, we can find this one along the curve. S1 is how much move to the position 1, and S2 is the distance moving along the curve to the position 2 from the origin. If I draw the Ft versus the S, this area underneath of the Ft versus the S is the work that is done by the force Ft. Now, what we can find from those equations, we need to learn about and also find the what's the relation between the force component and their respective coordinates. Also, if the relation is approximate or experimental, we need to use the numerical or geometric integration. Look like this. If you have the kind of experiment data, those experiment data are not smooth as I show you here. Okay, there are some noisy one. You need to do some numerical integrations and some numerical methods to find the integration of the forces versus the x. Now, can I move to the next slide? Yes? No? Going to the right? Can I move to the next slide? Now for the next slide, I want to show you how we can find the work of different forces. Force of external force, force of spring force, force of weight, or for general one, and force of the frictional force. Then I will start to solve another one, and we will start solve equations, the examples. First, if this force P is a constant external force applied to this particle or this body, that this force has an angle of alpha with the displacement along the x direction. This particle is just moving in this direction. Now, this constant external force, it is P. If we want to find the work that is done from state 1 to state 2, or from position 1 to position 2, if I use this equation, F dot dr, if I write the F in terms of the component, these are the terms of the component of the P along x and the y directions. This is Fx, this is Fy. Or inside of the bracket, This one is the F. Now multiplied by dr, the displacement. This one's a very simple example or simple problem. dr just moving along the x. Because if this one is moving along the x, this is the amount of displacement along the x is dx I. If this one is moving on the air, this dr will be dxi plus dyj. But this one is moving along the one direction. Now, if you do the dot product, with the product of the first multiplied by this, and the product of this multiplied by this, if you do, we will find this expression, dp cosine alpha dx. Or if I write here, for example, for the first sentence, p cosine alpha I dot dxi. This will be, because I by I is 1, this one will be p cosine alpha dx. For the second term, it's a p sine alpha j dot dxi. This will be p sine alpha dx. But j dot I, because it's 0, this will be 0. Now, if we calculate this integral, it is p cosine alpha dx equal to, p cosine alpha is constant because it's a constant external force. And dx will be x2 minus x1. And this is equal to this amount. It is L, x2 minus x1 is L, will be PL cosine alpha. Now, for this case, if alpha is 0, I push a box with the force of the P. Using this equation, the amount of the work that is done by P will be PL cosine of 0 will be PL. This one also exactly consists of what you learn about the work. Work that is done by the force is force multiplied by displacement. Work, force, displacement. This equation also is consistent what you learn in different. It is not denied and also just oppose what you learn. Then, how about this one? If I apply force P, how much is the amount of the work that is done by P that is perpendicular to the displacement? How much is it? 0. Why?
Because it's
Not moving and also is perpendicular to the displacement. Using this equation, you want to choose if P is perpendicular, will be PL cosine of 90 degree, it will be PL multiplied by 0, because cosine of 90 degree is 0. Also, from this one, I can conclude several things. What? How much is the work that is done by weight? If there's a box similar to this, I draw the free body diagram. How much is the work that is done by weight? Yes.
Is it 0?
Is it 0? Why?
Because the normal force is normal force stops at the weight.
Not normal force. Normal force is not cancel out with this one. Okay? Normal force is not equal to the weight for this condition. For example, if I apply a force of the P, this is not equal. For any condition that normal force is the weight, just something is staying. No applied force is applied in this direction. There's another reason. Yes.
There's no displacement in the direction of weight.
There is no displacement. Also, similar what I just concluded here. Force of the P is 90 degree with the displacement. This is the work that is done by the weight. It is 0. How about the work that is done by normal force? Also 0. It is perpendicular to the displacement. Next conclusion. If a frictional force applied to this one in the opposite direction of the motion, can you guess what is the work that is done by frictional force? How much is the work that is done by frictional force? How much? Can you calculate? Yes. No. Let's just write this one. You are close. It's okay. I want to find the work by frictional force or friction force. Yes.
Is it friction times L?
Is it friction force times L? Is it correct? Do you agree with your friend's opinion? Lawrence's opinion? Do you agree? Do you agree or disagree? There's two options, 0 and 1. Do you agree? Drew? Yes.
It's like it's opposing motion, so it should be negative force of friction.
Exactly. It's negative. Because if this one is moving this direction, frictional force will be in opposite direction. The alpha, I just write it here, PL cosine alpha will be 180 degrees. Cosine of 180 degrees is minus. The frictional force multiply L is correct, but it's minus. This is the reason if there is a frictional force in a system, you need to apply more forces to push something. This one cause reduce the energy you put into system or dissipated the energy. Now, let me copy this one. I just mentioned that the result can be interpreted. The component of the P in the direction of the displacement, or this part of the sentence, is P cosine alpha, is multiplied by displacement. This is the work. Also, the work of normal force or vertical components of the P do not do work. I just showed you. Finally, if there's a frictional force, the frictional force work, it is minus Fk or Ff multiplied L, assuming that the normal force is constant. Now, second one. If I go to the next one. There's a spring with the coefficient of K. It is attached to this one. It moves this one from x1, for example, this is the origin point. If I just elongated this one from x1 to the x2, for example, this one will be here, this will be x2. Now, I will give you the force of the spring force. It is Ks. K multiplied by S is the deformation. Or K x2 minus x1. How much the spring is deformation? Is elongated. Now, if I ask you to find the work of the Fs, can you calculate it? What is the expression related to the work that is done by force of the Fs? Can you find it? Let's try. Can you? Did you find it? Did you find it? Did anybody calculate? Look, we need to use this equation, F dot dl. You learned this. F here is the F of the spring. dr is just this one is moving along x. This will be dxi. Now, how much is the fs? Fs here is a minus kxi. If you do this one and do this integration, finally the work that is done by a linear spring is 1 over 2 kx1 squared minus x2 squared. Now, question. If I elongated the spring, it will be positive or is it the negative? Just elongate the spring. Positive or negative work? I will try this one in the G. Those string just connected to you. You want to just run, and this string just doesn't allow you to run. This causes a positive work on you or negative work on you.
Negative.
Negative. Also from this one, if you just extend this one, elongate this one, because x2 will be more than x1. This term is more than this. This is negative. The work will be negative. Something like in your life, you want to just improve your life, but something prevents you to just improve in your life. This means that just there is a negative work on your life. However, if you just compress the spring, if I compress the spring, means that the energy will be stored. Okay? If I release it, just adding some energy to the system. This is exactly consistent. If you compress x1 will be more than x2. This term will be positive. Means that the work that is done by compressed spring is positive. Now, these two sentences, this one, the work by a spring is negative whenever the absolute amount of deformation increases, and it is positive when absolute amount of deformation is decreased. It's consistent with the physical test. If you do that one, also it's consistent. Then, the units of K and X should be consistent. If X is meter, K also should be in Newton per meter. If X is in feet, K should be pound per foot. Make sure those were consistent. Finally, remember that X is deformation from on a stretch length of the spring. And note that the total length of the spring, for example, this, and not the total length of the spring. Any questions? No? Okay. Let's have 5 minutes break.
But it's like this one has so you can yeah.
It does kind of look like the wings. I'm seeing like yeah. Budget or just Is this for next summer? Oh. No. So,
Okay. Let's resume the class. Okay. Any question from first part of the class? No? Now, the next work is the work that is done by a weight. And how we can find this work? Work of the weight to the particle is moving along curved paths, moving from state 1 to state 3. We can find the work of the weight in this equation. I just put F minus mg belongs to the j direction by negative. Er is the dxi plus dyj. This one is not one motion along one direction. It's a motion along two directions, along x and the y. If you do the dot product, j by I will be 0, j by j will be mg dy, and finally, you can find that the work that is done by weight is minus mg y2 minus y. Now, if this one has a weight, right? This is one elevation just from the ground is, for example, y1. If I want to bring this one up, do I need to spend some energy or not? Do I need some spend energy to bring this one up? Yes. Means that to bring this one up, and I need to spend some energy from my muscle, and to bring this one up. Means that to bring one from one elevation, from y1 to y2, just this amount of the work is negative, because I need to spend energy to bring this one up. However, if I release this one from some height, this one has a positive energy. This one causes a kind of some impact. Okay? This is the reason. If I just release this one, the amount of the work will be negative, because y2 is less than the y1. This one is negative, negative minus negative is positive. The amount of the work will be positive. You have to be careful, especially for the work that is done by the weight. Also, this one is consistent. What I mentioned it before. I just mentioned that the work that is done, the weight, is 0. Because this one is just moving along one straight path. The y1 equal to y2, this is the reason. Also, the weight of this one, work of done by the weight for a straight path, it is 0. However, this, if released from some height to another one, this will be y1, this will be the y2, and y2 is less than y1. This will be negative. Negative multiplied by negative is positive. This negative sign, you have to not forget when you just want to write the work that is done by the weight, especially for the vertical directions. Now, as I mentioned, the horizontal displacements don't vary on the calculation of the work. If the work by weight is negative when particle rises, to rise something, I need to spend some energy. I need to give an energy. This thing doesn't give me an energy. I need to give an energy to the system. And also, it is positive if particles falls. When this one falls, you will see some impact. This one has a positive energy. If this one has a negative energy, it doesn't cause you some pain by release from top of your head. Okay? Means that also it damage to that once if you just head collide with something. Now, this is the work done by the weight. Can move to the next slide. Now, the work and for a curvilinear motion. If a particle moves on a curved path, general force or the resultant force applied to this particle with the mass of the m, and the position will be changed during the time, and this particle moves along this curve from state 1 to state 2. The work that is done between state 1 to state 2, you can find that F dot ER, and this one also is equal to FTS. Instead of F, I will use MA from the equation of the motion. And also, MA, if you remember using this equation, AES is equal to P. This instead of A, B, R also, I can write this one, M, B, B. And doing this calculation, this is the final proof. What does it mean? The amount of the work that is done by a force F with the particle, it has a curvilinear motion. It will depend the velocity at state 1 and state 2. This is the proof. I do not need to just, if you are not interested, it's okay. But this part show you the proof. What is important? U1 to 2, it is equal to 1 over 2m V2 square minus V1 square. Do you know what is 1 over 2m V square is called? Does anybody know? What is 1 over 2m V squared is called? What is this expression is called? Have you ever heard? What? I'm just hearing some voices. What is this expression called? Yes.
Negative.
Correct. Kinetic energy. This one is called kinetic energy. I use T to show the kinetic energy. This is love. The kinetic energy is T equal 1 over 2 mv squared. Kinetic energy is a scalar, also non-negative. The unit also will be unit of the work. Energy and work are same units. What I mentioned here, the amount of work done by all forces acting on a particle, it is equal to change in the kinetic energy of the particle. This one is called principle of the work and energy. This sentence is the interpretation of this equation. This one is U from 1 to 2 equal to change in the kinetic energy, delta T. Or if I add this one to the U12, T1 plus U12 equal to T2, the initial kinetic energy, T1, plus the work done by U12 equal to final kinetic energy. Means that, for example, if a particle starting with initial velocity, some external forces applied to the particle because work causing increase to them kind of the kinetic energy at the state 2. Okay? For example, you have a ring. This is moving with the initial velocity. So if you push that one, cause a kind of increase the speed of the ring. Just push and also roll it on the ground. This is exactly the same of this one. However, if one ring is just rolling, just you stop it, apply some forces in opposite direction, cause this ring decrease the velocity, decrease simultaneously. Similar to this one, the brake applied to the tires. Starting with the velocity, if the brake applied, brake causing a kind of a type of frictional force, negative inertia, cause this one reduce the velocity of the tire reduced. It is consistent also with the physical experiment. Can I move to the next slide? Yes. Okay. Now, why we need to use this equation? U1 to 2 is the T2 minus T1, or 1 over 2 m V2 square minus 1 over 2 m V1 square. First of all, from this equation, you will see no acceleration. Can you see any acceleration in this equation? No. Next one, we can relate the velocity change with the forces. Also, we only consider forces which do work. You will see from this one. For example, for a body just moving this direction, I apply a force of F. The work that is done by weight and normal force will be 0. I need to only consider the force F only, because this is doing work, not weight, not normal force. Finally, it's enable us to analyze a system of particles. For example, here, one type of this is an elevator just going up and down. You can relate the different type of particles with the kind of the motion and the work, and relate them together. Let's solve examples. First, we want to calculate the velocity of the crane at the state B, or position B, if started with the initial velocity of the 4 meters per second down from state A, the coefficient of the kinetic friction is 0.3. If I give you this equation, this problem, also you already can solve this one using the equation of the motion along the x. Similar problem I gave you for the homework. But however, for this problem, I want to use the principle. Work and inertia. When I ask you a specific method to solve a problem in the exam, in the homework, you have to follow exact method. You cannot solve another one. If I do not specify in the problem, you can use any type of method or any type of solution you know to solve the problem. However, if I ask you to use the principle of the work and energy, you have to use this. Okay? You cannot solve it. If you solve it, it's okay, but you cannot get the full credit. Maybe I will give you 5 out of 10. even though you found a correct answer. Now, using the principle of the work and energy for this one, if it started with at state A, just I put this one, this condition 1, state 1, position 1, moves to the state 2, position 2. Now, we are looking for to find the velocity at state 2 when the initial velocity it is 4 meters per second. The coefficient of the friction is 0.3. The mass of the crate is 50 kilograms. And we are looking for to find, I just mentioned here, into these are given. Solution, I want to use the principle of the work and energy. To use this, the amount of the work done by all external forces equal to difference between the kinetic energy. To find the amount of the work that is done by all external forces, I need to know what are the external forces. To draw the external force, I need to draw the free body diagram. If I draw the free body diagram, I can see what type of external force applied to the crate. Then I will start to find their work. Then add them together equal to T2 minus T1. And then I can find the velocity at state 2 or at position B and other area. Now, so I bring them here. Okay. For this problem, at this position, there is a normal force. There is a frictional force. If this is the x direction, this is the y direction. Also, there is a weight. These are all external forces. I do not show any weight or any velocity, any masses or those. I just show the free body diagram. Now, what I do usually, for example, we can do just write the forces and in front the work. If you sum all of this one, this will be u1 from 1 to 2, from this state to this. What forces I have? I have the normal force. I have the frictional force. Also, I can find the components of the weight along x and the y. If this angle it is 15 degrees, what is the component of the weight along the x? This one. What is the component of the weight along the x? Yes.
Weight sine of 50.
Weight sine 50. Yes. Also, this one is the weight cosine 50. Just so I write there. Weight sine 50. Weight cosine 50. Now, what is the amount of the work that is done by normal force? Yes.
0.
Correct. If this one is moving from state 1 to state 2, and this distance, whatever you mentioned in the problem, it is 10 meters. Now, what is the amount of the work that is done by frictional force? Yes.
Negative force and friction times L.
Correct. Yes. And this will be minus mu k multiply, and this is the frictional force. And L is 10 meters. This one moved 10 meters down to the slide. This one is important, guys. Minus is very important. Then, what is the amount of the work that is done by W sine 15 or weight sine 15? Next one. How much is it? W sine 15. Yes. How much is the work? Somebody mentioned. Yes.
Is it 12.9?
I do not have the number, to be honest.
Oh, I
It's
guess
okay. Thank you. Maybe I will calculate it. It's a W sine 15 multiplied by 10. If we calculate it, I think that might be 12.9. Next one. What is the amount of the work that is done by W cosine? Yes.
It's a 0.
0. Now there's summation. If I just sum all of these ones, it will be minus mu k and multiply by 10 plus W sine 15 multiplied by 10. We have the weight. We have the coefficient of the friction. But we do not have the normal force. How can I find the normal force? Yes. Yes. To find the normal force, just you will see that yes, normal force will be along the y direction. This you need to use the equation of the motion along the y direction. Equation of the motion along the y direction equal to 0 means that the forces along the y direction, it is equal to 0. We have only two forces along the y. One normal force, one W cosine 15 that is in opposite direction. This will equal normal force minus W cosine 15 equal to 0. Normal force can be found adding. The mass is 50. G is 9.81 multiplied by cosine of the 15. The normal force will be 473.8. Now, if I substitute this one into this equation, I can find the total amount of the work is done by all external forces. This one is equal to minus the coefficient of the friction 0.3 multiplied by normal force of the 473.8 multiplied by 10 plus the weight, it is 50 multiplied by 9.81 multiplied by sine 50 multiplied by 10. Now, if you calculate this one, let me see if I have it or or somebody can calculate this one. So did you calculate? It will be minus 151.9 joule. Joule. This is the unit. Now we have the summation of the work that is done by all external forces when this box or this crate moves from state 1 to state 2. What this one means that there's some negative work, just something push this one to just not moving downward. It's a negative energy. Now, if I return back to this equation, let me go to the next slide. Can I move to the next slide? Yes. Okay. Now, summation of the work that is done by all external forces equal to 1 over 2 m v2 squared minus 1 over 2 m v1 squared. This one, it is 151.9 equal to 1 over 2 mass 50. We are looking for to find the velocity minus 1 over 2, 50. The initial velocity is 4 square. Now, we calculate the velocity. Velocity will be 3.15 meter per second. And this is the answer. Got it? Now, can I move to the next slide? Next slide. Also, there's a crate, two forces applied, 800 Newton and 1000 Newton. Similar to this one, I will give you for the homework. And if it's originally at rest, we want to find the distance that it slides. In order to attain the speed of 6 meters per second, the coefficient of the kinetic friction between the crate and the surface, it is 0.2. I will give you 1 or 2 minutes. Just think why you want to start to solve it. I will stop. Okay. For this problem, what is given? The mass of the crate, it is 100 kilograms. Subject to two forces. Okay, one, it is 800 Newton that has component along the x. Component along the, if this one, this direction is x, this direction is the y direction. The component of the force along x is 800 cosine 30. And what is the component of 1000 Newton along the x? How much is it? Yes.
There would be 1,000 cosine of gain 300. That's cosine of gain will be 36.887.
Okay. And how much is the final product?
That's 800.
How much?
800.
Correct. This one is 800. Why? This angle, we have the relation here. Cosine of alpha is the neighbor 4 divided by this length 5. You do not need to just convert and find the alpha. That's enough because this one, it is 1000 cosine alpha. Also, along the y direction, there is a force of 800 sine 30. And also for this one, It is a 1000 sine alpha. That is, sine alpha is 3 over 5, or it is 600 Newton. Now, starting at rest, initial state 0. We want to find the distance, how much this one moves, to attain the speed of 6 meters per second. And the coefficient of the friction is 0.2. For this problem, I want to use the principle of the work and energy. This principle is that the amount of the work that is done by all external forces equal to T2 minus T1. Or this one is equal to 1 over 2 m V2 squared minus 1 over 2 m V1 squared. This is 0. Why? Because 1 is 0. Also, it is equal to 1 over 2 m. It is 100. V2, it is 6 squared. What we need to find the amount of the work by all external forces. To find it, I need to draw free body. Now, because I already do this one here, I want to bring this one next slide. Now, other forces that we have the weight, normal force, and if this one is moving this direction, there is a frictional force. I just write this one with a blue color. Now, what I can do, make a table. It's not necessary, and also it's not mandatory to say just make a kind of table as I did it. Just this is in more detail. You want to see how I found the forces and the work of the different forces. You can write the expression just when you just practice more and more. You do not need to just write and also just make a table. But this is for better understanding of the forces and what are their work. You will see that we have some forces along the Y. I use red color. Also, we have some forces along the X, 800, 800 cosine 30, and frictional force. These are all forces I have. Step by step. How much is the force of the first force? 800 sine 30. 0. How about weight? 0. How about normal force? 0. How about the 600 one, just this one? 0. The reason I just wrote those forces with the red color to show you that the forces along the y direction, their work are 0. If this one moves D from state 1 to state 2, how much is the force that is done by 800 newtons? How much? I need to get a hearing aid from Costco. I cannot hear from. How much is it? 800 times B. Times B. Fall down. 800 times. Similar for 800 cosine 30. Also will be 800 cosine 30 multiplied by D. And also, the frictional force will be minus because it's a negative, it's minus. Frictional force multiplied by D. Summation of all of these ones will be U1 to 2. Just this is 0, 0, 0 plus. This will be 800 D plus 800 cosine 30 multiplied by D minus frictional force multiplied by D. This frictional force will be mu n, or the kinetic coefficient of the friction, by normal force. Also, we need to find the normal force, as I did it on the previous slide. If I write the forces along the y direction equal to 0, just y, I need to find normal force. The forces along the y, the forces with the red colors, normal force minus weight minus 800 sine 30 plus 600 equal to 0. If we calculate this one, normal force will be 781 newton. Then, if you substitute normal force into this equation and adding those numbers here, that they are 800 plus 800 cosine 30 minus the coefficient of the friction, it is 0.2 multiplied by 781. All of brackets goes and multiply by D. If you calculate this one, it is about 1336 approximately. Multiplied by D. Now, I found the work that is done by all external forces. It is 1336 multiplied by D. I will equal this one with this equation. This, I found it. 1336 D equals this one. If you calculate it, multiplied by 36 is 800 Then if we divide by 1336, d, or the amount of the distance moving, it is 1.35 meter. This is the answer. Got it? Any questions? No questions. Oh, yeah. If you want me to go to the next slide, I will go on next. Can I move to the next slide? Yes. Just write it. Okay. Can I move to the next slide? Yes. Now, let me stop for one more slide, then you have to go. I will post the homework 6 now. There's 4 questions. 2 related to previous lecture, 2 related to the today lecture. Also, I will post some practical examples. The due date will be on them on next Thursday. The problem will be similar to what I saw in the class. Also, if you refer to the class homework, you can find those. Please do those ones. If you have any questions, next class, ask me any question regarding the homeworks. Okay? I can help you. Please come here. Just do not afraid or just do not think that I do not answer your question. Also, if you want, also I can give you the solution too. Okay? What I want from you, you need to learn it. How you can learn? You need to solve it. If you have some mistake, you can learn from your mistake because I post the solution. Do not do those homework and also just see the solution, and because the exam will be closed, just looking to the solution is not the only way how you can learn. You need to write it, practice it, then you can get a good grade in the exam. Okay, guys, any questions? No? Okay, thank you for coming to class. See you on next Thursday.
I just had a quick question.
Yeah.
Yes, is it going to be on Monday or is it going to be on?
No, just stick to the point. Just next Monday we will have radio, and also next Thursday we have
Okay, sounds good. Thank you.
Let me
Okay.
good.
Thank you.
I'll see you Thursday.
Here.
Yeah.
Yes.
I was the one to,
Yeah.
decided it's like 0.5, but I know it's not. I just, everybody, yeah. On my phone.
Sit.
I know what to say.
What I want to ask? You like the black was
I'm not using my phone.
okay, yeah. To be honest, this is the my account. Next time, just check it with me. For example, this one, especially for the kids, you don't have the problem.
Yeah, I really just
The
want
kids are really different.
Yeah.
Why trust? I don't think. Can you, no. Okay. Do you have it?
I have it
The
right
point?
here. I can, yeah, I'll
Yeah.
send it to my laptop, I'll try to submit it on my laptop.
So, let me, I connected with the, while I'm posting the
How about-
solutions and everything, we can submit it.
On my phone, I have pictures of like the dates, so like the dates associated with you.
No. I trust.
I know the homework where like.
Look, to be honest, there are reasons in the blackboard, it's just when there's something not submitted, just put this.
Yeah.
I show you that picture. It's not submitted, it's just this amount. Unfortunately, I have not. I just a good one that I just put. You have the review exam, right?
Your exam, homework 3, 4, 4.
I think that the homework 3 you got it. Some problem. Let me see. You have the let me see. Now the exam one is you can see. Okay, review exam. And the homework 3 and 4. Homework 4. I'm open those ones. Just submit them now.
Okay, yeah, those will
Sorry.
be, those will be in the next hour.
Yeah.
Lovely. Thank you so much.
Can you submit until when? I just want to put this on
Next hour?
next hour.
Yes. I'm gonna do it soon, I'll get back to my work.
Okay, this. Today is 23. Now it's 3:25. I will give you the 5. Okay. Good. Let me see. It's okay. No, stress is not good. Stress for your life is not. Do not have a stress. When you have to have a stress, when your kids just have the heads to the
Yeah.
down. That was the stress. You will have lots of stress in your life.
Okay.
Do not make a
This is
stress
not-
for not important things.
This is.
Yeah, exactly. I just put it here until 5. Then put the stress because I'm driving. Okay, good.
Thank you, sir.
You're
Appreciate it
welcome.
very much.
You're welcome.